Emissions are top of mind for many oil and gas operators, as we've been discussing today, and ArcGIS can play a key role in helping to mitigate emissions. There are dozens of monitoring technologies that are being used today across the industry, and location ties all of them together as everything happens somewhere. ArcGIS can integrate these data sources from multimodal monitoring activities. But it's more important than just monitoring. It's also about responding to minimize emissions and compliance risk. As well, you'll see that maps can play a key role in communicating with stakeholders and anybody who needs to see this data to make decisions. ArcGIS provides 5 key capabilities for emissions monitoring. The first 3 are methods of monitoring: field mobility for inspections, remote sensing of all types, and IoT for connected devices. Each represents a data source and input into ArcGIS. Then there's the system of record and the system of engagement. This is where your data is centrally managed and accessed through applications like dashboards, where you can track key indicators and overlay this monitoring data onto your assets. And then finally, stakeholder communication. Everybody can understand a map, and you can use maps that we'll build as tools for transparent communication. For remote sensing, data is being captured from satellites and aircraft to drones and ground-based devices. To manage these, you need tools that support these diverse arrays of remote sensing platforms and formats. It also manages all scales, right, from global data sets to specific sites where you might use drones. And on the topic of drones, increasingly, we're seeing these be used to inspect difficult to reach areas with high resolution and more diverse payloads, such as thermal cameras for site inspections, or drones being used to generate 3D models for context. When there's gaps in remote sensing, you can fill in with ground-based inspections. Form-based inspections for facilities are used to build up a record of site visits, capturing pictures, notes, and of course, a location. And if issue is detected, then a report or an alert could be generated and sent to the appropriate individuals. The visual inspections really only represent one point in time, and they require personnel, time, and resources, and they're not feasible for comprehensively monitoring entire operations. So in addition to remote sensing, what can help is IoT devices and sensors. By connecting your maps to all these IoT devices, you can visualize alerts geospatially. This could represent locations where there's thief hatch sensors, stationary cameras, gas detection equipment. All these different sorts of IoT devices can be connected and visualized. Generally, some combination of inspections, remote sensing, and IoT devices together will be used to monitor most operations. A central system of record can manage all of these data sources and enable you to visualize them together with your core asset data, such as acreage, facilities, wells, and more. ArcGIS can help to break down these data silos between independent sources of monitoring data and bring them all together under one system of record. And finally, maps, after you've built the system of record, integrated these data sources, they're a common language that everybody can understand. You can leverage these data sets and maps that you build and reports for transparent communication with all stakeholders. With that, let's go look at what this looks like in practice. Here, we're looking at a fairly typical operations map. I can see acreage, operating areas, field offices, wells, and much more. This data all provides context for the other emissions data that we'll work with. First, we'll look at remote sensing, where I'm using several data sets from GHGSat, an Esri business partner. GHGSat provides global emissions monitoring from a constellation of satellites that helps to identify large leaks fast. On the map, red and orange indicates higher methane concentrations. This is a weekly average data set with updates every single week. On a specific and more targeted basis, GHGSat can also task satellites to achieve higher resolution data. They can provide alerts or analytics to highlight and specifically show you where potential plumes might be. Leveraging this global data set, though, you can manage your operations by exception when it comes to inspecting assets that might be leaking greenhouse gases. This data set does not tell us where leaks are, but they do enable you to intelligently plan where you should inspect. Facilities in areas of higher concentrations can be on the top of your list for where next to go with an inspection camera. I've opened up ArcGIS Pro, where I've gone ahead and performed this analysis. Each dot represents a facility that some type of equipment could be leaking from. We can extract the methane levels at each of these sites from the GHGSat data and identify the top 100 facilities that we should be inspecting within a given week, highlighted there on the map in blue. Then we can generate optimum driving directions based on these locations to say where we should visit in the most optimal order, maximizing the number and the quality of inspections. Now, this brings us to the next method of monitoring, which is around field inspections. Now that we have this optimum order of stops, we need to go into the field to actually perform the inspection. I've opened up my tablet, and in the field, what I can see are my regular emissions inspections that were generated just a moment ago in ArcGIS Pro. But I can also see a critical priority assignment that's been given to me to go out and inspect an alert that we received from GHGSat. From here, I can navigate directly to the facility and perform an inspection. I can provide information on what I'm inspecting, such as what equipment I'm inspecting, what equipment I'm using to perform the inspection, and whether or not I observed any gas leaks. I'll also answer the question whether there was a leak, whether I repaired the leak. If the answer is no, a follow-up repair will be scheduled, and I can provide any pictures at the bottom for reference. Back in our dashboard, we can now see a list of inspections that we can interact with, and KPIs telling us how many inspections have been completed, how many where gas was detected, and how many of those that were fixed, and giving us an idea of what work needs to be done and how much work has been completed. As well, on our map, I can see the location of all of these different inspections shown as green dots for good ones and red exclamations for issues that were detected. One of the most cost-effective ways of monitoring them is with IoT devices. Devices could be detecting gases or detecting something known to cause emissions, such as in this facility, an open thief hatch sensor, or down here, the camera, which detected gas. Vehicle-mounted sensors are another source of data that can be visualized. Here, each of these dots corresponding to a methane concentration picked up from a vehicle, where this color represents lower concentrations, orange, higher, and red, the highest concentrations. ArcGIS can ingest all of these different types of real-time data streams for visualization on this map, or for geospatial analytics, potentially finding clusters, identifying potential culprits of these issues, and more. By combining all of these different sources of real-time data, imagery data, field mobility, you can comprehensively monitor emissions and respond effectively. From preventative maintenance and inspections to finding the largest leaks and responding to them, you can know when and where you've conducted work, enabling you to pinpoint leak durations, for example, for reporting. Aside from viewing this data in ArcGIS dashboards, you can also bring this into reporting applications like Power BI. Here, we're looking at a slightly different example of data where here we're seeing flaring intensity from the satellite observations. The heat map indicates where flaring intensity is highest, and I can filter this data down to look at specific months of different years to find where intensity has changed over time. but I have access to all of those other geospatial data layers that we had within our dashboard, such as our global methane concentrations from GHGSat, our specific observations from things like vehicles, satellites, sensors, and much more. As emissions monitoring becomes more and more necessary and commonplace, you can be prepared to use that data and to actually respond and to minimize emissions and costs. ArcGIS can then integrate IoT data, GIS data, remote sensing, field inspections, all into one common operating picture. So you can generate information products for operations teams, executives, analysts, and more. With that, thanks, and back to you, Sam and Tiffany.